Hello everyone, I'm Stefano Caioli and I'm here today to present you a very convenient way to deliver web contents on the internet. Let's start. We may see the classic way to deliver content on the internet. A client, a user using his own computer and his own browser or maybe a mobile phone, type on the bottom line of his own browser the URL of the page or the website he wants to visit. After that, a DNS server somewhere on the internet translates that human-readable address in an IP address. That IP address is assigned to a server, the server which holds the content the user wants to see. The server, in order to answer to the user request, starts gathering the information from his own resources. That means databases, that means hard drive and file system, and also external and other websites. The web page is composed from many resources, not only static content, but also dynamic, which are composed reading at real-time databases and resources that may be outside the server itself. After that, the web pages is delivered to the users using a web server, which usually is Apache. As you may imagine, the answer of the server is strongly dependent from the number of the users that request a specific page, web page, or in other words, also different pages that are hosted on the same server, because of course the resources are the same. So in the next slide, we are going to see a new infrastructure in order to get rid of these problems. As you may see, the title of the slide is Varnish-based web server service landscape, because this infrastructure is based on a service which is called Varnish. As we have seen in the previous slide, the client, the user, type the URL on the top of his browser. Same thing, somewhere a DNS server translate that human readable address. Then a web server is contacted. This time, the web server with Apache is no longer on the internet, but it's beyond a LAN, a local area network. That means that it's not directly reachable like it was in the slide before. In this time, we have a service which answers in behalf of the Apache we have seen in the slide before, which is called Varnish. Varnish, what's that? Varnish is a caching system. That means that a web page which has been requested from a previous users is held in memory. So there is no need to gather each time a page is requested the information from different resources, as we have seen in the slide before. The result is that the answer is dramatically fast and the load on the server is very, very low. What is the limit of this infrastructure? Varnish does not handle HTTPS requests. That means the requests that are protected by SSL, Secure Socket Layer. As you may imagine, with all the threats that are on the internet in these times, almost every website is moving on this technology in order to secure the communication between the server and the user. The problem we have to face is to use Varnish also for HTTPS. Varnish by design does not support HTTPS protocol and so the secure socket layer communication. So we have to find a way to make Varnish to be able to handle this kind of communication. To do that, we use another service, which is NGINX. NGINX is almost the same thing of Apache, is a web server. The NGINX supports SSL communication. So what we do is to put on the front of the server this service. This service answers to the HTTPS request and then forwards each request locally to the Varnish service. In other words, the SSL communication is handled by NGINX, and the communication after is decrypted is sent locally to Varnish. And this is the way we can handle HTTPS also with a system and a service, Varnish in this case, which does not support this kind of protocol. In the slide, we also see a switch, blue and black box in the middle of the server, which is the way that these two servers communicate. And the web server that we have seen in the first slide is now beyond this switch, not reachable directly from the users. When is contacted the server? Very simple. When the user requests a page for the first time, the web server below in the slide is contacted because it holds the content of the web page. After the first time, Varnish, the cache server on the bottom of the slide, holds the content in memory and does not need to ask to the web server anymore the web page because it has the content. All the content is in memory, in the cache memory of the Varnish service. So there is no need to access different resources, and there is no need to bother the web server any longer. So each time that specific web page is requested, the Varnish Cache service answers without asking to anything else. Of course, it's not mandatory that you have separate servers. You also may use the web server's Apache on the same server you are running Varnish and NGINX, just changing the service port. The service port is the socket port on which the service is answering. For instance, HTTP is using port 80. HTTPS is using port 443. So these are the ports on which the users and the standard service expect to find the answer for the web content. So if you move your web service, your backend web service on a different port, let's say 500 or another port you wish, which is not already used by another service, you may tell to Varnish to ask the web content, in case it's not already in cache, on this port on the same server of the Varnish. So you save one server in case you have enough resources on that server. That could be a possibility. But if you are experimenting this infrastructure, I strongly suggest to keep these servers separated. Let's move to the next slide. Of course, it's not mandatory that you have separate servers. You also may use the web servers Apache on the same server you are running Varnish and NGINX, just changing the service port. The service port is the socket port on which the service is answering. For instance, HTTP is using port 80. HTTPS is using port 443. So these are the ports on which the users and the standard service expect to find the answer for the web content. So if you move your web service, your backend web service on a different port, let's say 500 or another port you wish, which is not already used by another service, you may tell to Varnish to ask the web content, in case it's not already in cache, on this port on the same server of the Varnish. So you save one server in case you have enough resources on that server. That could be a possibility. But if you are experimenting this infrastructure, I strongly suggest to keep these servers separated. Let's move to the next slide. Performance. Varnish is a reverse web proxy, which is the exact name to describe the kind of service it delivers. In other words, is an accelerator that caches, keep in memory, the HTTP content, and with the solution we have seen in the previous slide, also the HTTPS contents. The request can be speed up by a factor of 500 up to 1000 times. That's very impressive. If you imagine that to achieve the same result with the classic web server, you need a cluster of 500 up to 1000 server to deliver a page instead of one single server. How Varnish achieves this result? By caching and saving CPU time and database requests for content. Varnish is able to serve hundreds of consecutive requests per second, as I said before. You may ask in the next slide, what happens if the content of the web server changes? In the meanwhile, the Varnish cache is serving the web pages to the users. Of course, it's a very important and common question. So there are basically two ways to achieve the goal to clear the cache of the Varnish service. The first one is to restart the service. This way we clear all the cache for all the web pages that were stored in the Varnish cache memory. So the next time a web user is asking for a web page, the Varnish cache has to reload that web page from the web service. So from the server that you have seen in the previous slide, that is beyond the switch on the LAN. Of course, there is also another way. If you only change the content of a specific web page, you may use curl. The way is described in the bottom of the slide. So you may specify only the page you modify on the web service in order to avoid to reload or to ask from the Varnish cache the whole content, web content, to the web service on the other server. Let's get to the last slide. I won't tell you nothing about the configuration on Varnish and NGINX services because there are a lot of good tutorials on the internet. But I want to warn you about a common pitfall using the Varnish cache system. Keep in mind that for the Varnish cache system service, all the web pages are considered as files, so as open files. So you have to be sure that your operating system is able to handle the number of open files you need to serve the web pages to the final users. To do that, you have to modify let's say three configuration files inside your operating system. If you don't, the result may be a denial of service. In other words, if the number of web pages requested by the users are greater than the number of open files that your operating system may handle, the Varnish cache does not answer to the final user. So it results in a denial of service. To avoid that, you have to specify the number of open files that you can handle, as you see in the slide. You have to modify the file systemcontrol.conf, which is in the folder etc, the file limits.conf, which is in etc security, and if it's not already set up, as you see in the bottom part of the slide, you have to modify the common session under the pam.d folder under etc in order to require the module pam_limits.so. That's all. Thank you very much for your time. I hope you enjoyed the tutorial and you find it interesting and useful. Have a nice day. Bye bye.